Good afternoon. Today we're going to be discussing graphing. It's our first assignment over graphing, rectangular coordinates and graphing. And maybe I need to there. Okay. I think we mentioned this semester that this isn't an introductory algebra class. By that I mean that sometime you've had some algebra to be able to place into this class, and somewhere along the way you would have seen graph paper and the rectangular coordinate system. That's just a fancy name for the x-axis and y-axis. The x-axis is a horizontal number line. The y-axis is a vertical number line. So y-axis, x-axis. On the x-axis, the positive numbers go to the right, just like the number line. And negative numbers go to the left. I think I'll increment by 2. Negative 2, negative 4, negative 6, so forth. 3, 4, 5, 6, 7. The vertical number line, the y-axis, the positive numbers go up. So 2, 4, 6. Negative numbers go down. Negative 2, negative 4, negative 6. And we graph ordered pairs on graph paper like this. An ordered pair is in the form XY. Ordered pair. It looks sort of like those open intervals we saw the last time when we were using the cut points and had 2 open circles at the end points. But here, this first number is called the x-coordinate, the second number the y-coordinate. The first number tells you the horizontal movement, how much to move left or right. The second number gives you the up and down, the vertical movement. If that second number is positive, you're moving up. If the second number is negative, you're moving down. If the first number is positive, you're moving to the right. If the first number is negative, you're moving to the left. Again, I'm sort of assuming that y'all have seen this somewhere along the way. And if I wanted to plot the point 2, 4, I'm going to plot it in purple ink. In order to locate this point on our rectangular coordinate system, we start here at the intersection where the zeros are. And I'm going to go ahead and give the name to that point right there. That's called the origin. That's where you start to locate the number, the ordered pair 2, 4. The first number is right or left, the second number up or down. So we're moving right 2, up 4. Right out there. Right 2, up 4. Now let's suppose we want to plot the point negative 2, 4. Well, negative 2, 4 would be over here in what's called the second quadrant. Notice how the rectangular coordinate system is divided into 4 regions. Each one of those regions is called a quadrant, and you number them starting with the upper right-hand corner. That's quadrant 1. Over here, quadrant 2, quadrant 3, and finally quadrant 4. I'm going to go around from quadrant to quadrant, plotting a point. Like -2, 4, that would be over here in quadrant 2. Could y'all plot it? You'd move left, start at the origin, left 2, while left, because the first number is positive, up 4. So left 2, up 4.
Does it always start the top right is going to be quadrant 1?
Uh-huh. If you go into, say, a trigonometry class and your teacher says quadrant 1, they're talking about up here, okay? If they say quadrant 3, it's universal. It would be this quadrant down here, okay? I suppose I could mention that in some physics classes, this rectangular coordinate system is set up differently, but the positive numbers going down on the y-axis and negative going up. If you've ever seen it like that, I'm not doing it wrong. This is how it's done in math. Huh?
It's like it's coming back. When I'm like,
Oh, yeah. If it's been a while, you'll just have to work at it a little harder. Like in quadrant 3, that's supposed we were plotting the point -2, -4. Would that be in quadrant 3? -2, -4. We'd be moving left 2, down 4. And the key to every type of IQ test involves spotting patterns. Could y'all guess what the last point that I'm going to plot over here is? 2, -4. Exactly. We want to plot the point 2, -4. That would be right 2, down 4. We're going to have a really nice way of plotting these on the computer. Pearson has a nice little software built into these. In general, we could say this. In quadrant 1, x and y are always positive. I'd write plus, comma, plus. Could y'all do the same thing for quadrant 2? It wouldn't be positive, positive. In quadrant 2, the x value is always, okay, like here. I'm thinking it's negative, positive. Left and up. Is quadrant 2 always going to be negative, positive? What about quadrant 3? Negative, negative. One more, quadrant 4, positive and negative. Now, it's possible to have points just on the x-axis or the y-axis. If you wanted, let's see, what color have I not used this? In blue, if I wanted to plot the point 7, 0. That's neither in quadrant 1 or quadrant 2 or 3 or 4. It's on which axis? Okay, you'd move right 7, up 0, right there. So the point 7, 0 is actually on the x-axis. And one more, let's plot the point 0, -6. Trying to use numbers I've labeled on here. Where would 0, -6 be? On the x-axis or on the y-axis? Y-axis. You would start at the origin, move left and right 0, and then down 6. Why down? Because it's negative. Okay? Now, the first thing we're going to graph today are going to be lines. We're going to graph a lot of little figures today. In general, the equation for a line looks like this. AX plus BY equals C. Well, what the heck does that mean? Well, the A, B, and C are just numbers. The X and Y are the variables. If you have an equation has equal sign. If you have an equation and there's no exponents in it. Oops. Need to remember to move that cursor some, but I'm just rambling on and on. But if you have an equation and there's no exponents in it, but we're going to see how to graph one that has an x squared in it today. I think we're going to see some equations that have an x cubed. But if there's no exponents in it, that's just a line. And what's the bare minimum number of points you need in order to graph a line? 2. Okay? You need 2 points to graph a line. And a point is an ordered pair. And I think I've talked enough. Oh wow, that looks terrible. So messy. Let's start with problem number 1. I did glance through these and I noticed that I think problem 3 and my number 7 were the exact same. So I got it wrong, regenerated it, so we could have different. Does that happen to y'all sometimes? You wind up with the same problem? Okay, this is problem number 1. It says, give ordered pairs that are solutions and graph the equation. When I look at that equation, problem 1, I see that there are no exponents. So I'm thinking, oh, that is a line. 4y equals 3x minus 12. And what they're giving us here is an xy table. Let me write out that xy table. What we're going to be doing here is plugging in. Like on the first line of that table, there's a 0 in the x column. You want to guess what we're going to do with this one? Here, I've written it down. What is it trying to tell us to do with this? There's a 0 in the x column. What it's saying is, plug a 0 in for x and find the y. So plug a 0 in for x, and we would have 4x. I'm plugging a 0 right here. Sorry, I said 4x, I think. I meant 4y. Equals 3 times 0 is 0. Minus 12. Is that a negative 12? Whenever I'm doing problems like this, I think back to years and years ago when I had a student. We'd be doing, okay, plug a 0 in here, 18. It took me a while to figure out what the heck was that student doing. How was he getting 18? Do y'all see it? He plugged 0 in and got an 18. What's he doing? I'm embarrassed it took me so long to figure it out. 3, 0, that's a 30, minus 12, he got 18. And I was like, oh wow. I mean, once I told him what it actually meant was times, but I was shocked because it was college algebra. I would have thought he would have gotten that straightened out before then. But a young guy, fresh out of high school. But anyway, I always think, what if someone says, like for this 18, if you do, I'll know what the problem is, okay, what you're doing wrong. It took me a while to figure it out. Because, you know, I'd say, no, plug in the 0, and he'd say 18. And I was like, what the heck is he doing? Finally, I looked at it, and it dawned on me. But anyway, so now plug the 0 in correctly. This means 3 times 0. So 0 minus 12, it's just a negative 12. Then what do I do to solve for y?
Divide by 4.
Yeah. So what are we going to get here? Y equals negative 3. Okay. We're going to have to plot that ordered pair in a moment. So I like to put the ordered pairs in parentheses, but they don't do that. Oh, why do I still have that showing? So I'll plug in what number here? A -3. Check my answer. Let me move this all the way over here. Okay. Oh, now what do y'all think the second row is telling us to do? Notice that the 0 is under the Y column now. So what do you think it wants me to do here? Plug the 0 in for Y and find the X value. So I'll do that right. Well, maybe I'll do it down here. Plugging the 0 in for Y, that's not 40, is it? It's 4 times 0, so 0 equals, ooh, running out of room. So plugging a 0 in for Y, 4 times 0, 0, equals 3x minus 12. Can y'all solve this for x now? What would we need to do? Add 12? I'd move the 12 over. If you want to move the 3x over, okay, you're just going to have more negatives. But if you leave the x on the right and move the 12, I think you'll have no negatives at all, will you? So we have 12 equals 3x. Divide by 3 to get x equals 4. So we have two ordered pairs, 0, -3, and 4, 0. Come over here. What number am I typing in there? A 4? And now it says, this is the first time this semester we've used these graphing tools. We're going to graph it right here. And to show the whole thing, I'll click right here where it says click to enlarge. It doesn't really enlarge it. It just enlarges this whole graphing area over here. And the yellow instructions up here sort of walk you through how to use this stuff. Okay? You have your x-axis and your y-axis. The first thing it says is click the graph and choose a tool in the palette and follow the instructions to create your graph. Okay, so the first thing you do, you click a tool over here. If you hover, it'll say the name of the tools. It's sort of hard to see. Let me see if I make this larger. Oh, nope, maybe I made it too large. Okay. If I hover right there, it says line tool. Look right here. It says absolute value tool. Right here. Well, we'll discuss those other tools as we move through them. But this is a line. Okay? It said that in a line, there should be no exponents. Okay, just x and y without any exponents. So, you click on the line tool. And it now says, click the graph to plot the first point on your line. What was that first ordered pair that we got here? 0, -3. So move around and find 0, -3. And I'm going to have to make this smaller because it's cutting off something that's important. Oh, gosh. Okay. One more. Something's going on here. Let me just click again. So we chose the line. Now we're going to, oh, okay, good. It's showing these numbers up here. That's the ordered pair where your cursor is. Okay, I was way up here at 10, 10. What's the ordered pair we've got to click on? 0, -3. Is that first one? 0, -3. Look real closely. Are we at 0, -3? Yes, look in the upper right-hand corner of that yellow rectangle up there if you're not sure what point you're on. So we'll click that. And then it says click the graph to plot the second point. At this point, it's going to show you every line that passes through 0, -3, if you can imagine that. The second point I'm going to click on is 4, 0. Am I at 4, 0? Yes. How do I know I am? Upper right-hand corner of the yellow rectangle. I click there. Then you can't check your answer yet. If you look at that, what you have to do is you say save. It'll put it onto this graph, and then you can say check your answer. Okay? It's a nice little graphing tool. Going to see several of these graphing tools over the next few weeks. Problem 2 is the same type of problem, except instead of being given an XY table, they're just writing the ordered pairs as ordered pairs. I like the XY table, but it's okay. Let me move to another page and write down the problem. Okay, problem 2. 4x plus 5y equals 20. And we're given the ordered pair 0, blank. So it says y value here that we got to fill in. So, in words, what am I going to do? I'm going to take the 0 and plug it in for x. So the 4 times 0 would just be 0 plus 5y. So just 5y on the left equals 20. Is that one that we can solve pretty easily for? Solve for y by dividing by 5. Y'all caught up? Y equals 4. So I type a 4 in. Here. Check answer. I wonder what the next one's going to be. Do y'all have an idea of what are they going to have us do for the next one? Okay, yeah. That's what I was thinking. You're going to plug a 0 in for y. Notice the 0 is in the y position. Sometimes students say, oh, I can do this. I can get this answer without writing all this stuff down. Do I have to write all this stuff down? I would say, no, you don't have to write it down. If you can do it in your head, your goal and my goal are different. Your goal is to get the answer as quickly as possible without using what's it called, photo math or one of the little cheating tools. Okay? You can do as much as you want in your head. My goal is to try to show the thought process. So that's why at times I'll be writing stuff when you're like, oh my gosh, it's obvious the answer's 5. Plug a 0 in for y. The 5 times 0 is just 0. So we have 4x equals 20. Divide by 4. And 5 is the answer. 5. This is very similar to the previous problem. only difference is it's just writing ordered pairs rather than the little XY table. How we do that for graphing, since there's no square root, or excuse me, since there's no exponents or heck, even square roots or absolute values, there's just X and Y. It's a line, so you click on the line tool. Now, what was that first ordered pair? Over 0, up 4. And the second one is right 5, up 0. Notice if you move your cursor around, if you click on a point and want to change it, you can clear it and stuff. What I always do is I just exit out. If I click on the wrong point, I exit out and start it over again. Right 5, up 0. Oh, I forgot to show you that it said right 5, up 0 here. But you can click and drag it around if you need to. If your hand moves as you're clicking on this. So I'll say save it. And check it. Okay. Any questions? Our next assignment is going to be over nothing but lines. Hard to believe we're going to spend a class period over the easiest stuff to graph. But there's some terminology that's introduced in Math 371, the developmental math. And I want to mention it now in case it pops up before the class meeting on Wednesday, before our next assignment. The x-intercept is the point where the graph crosses the x-axis, or let's say intersects the x-axis. So we have something called the x-intercept and the y-intercept. The point where the graph intersects the y-axis. Another reason I'm mentioning this is I think that that's what we just did. If you look back at these graphs, the two ordered pairs we were plotting weren't those on the x-axis and the y-axis. So on problems 1 and 2, if someone asks, what are you doing there? You could say, we're plotting lines using the x and y intercepts. Like right here, this point right, oh, let me just do this to make it, oh, why did they do that? They didn't, I'll just use it here. Over 0, up 4. What would y'all call that point there? The x-intercept or the y-intercept? The y-intercept. Like right here, that other point 5, 0, that is the x-intercept. Let's look over here at number 1. Let's see, right there where my cursor is. Can y'all see it out there? What is that? The x-intercept or the y-intercept? Well, it's crossing there at 4. Right here. I'm thinking it's x. Y'all see where my cursor is? Right out there. That's the x-intercept. And right here is the y-intercept. So you might notice that in order to find those intercepts, what were the numbers we were plugging in? Like right here for the first one, we had to plug a 0 in. And right here on the second one, plug a 0 in. Plugging in zeros gets you those intercepts. Okay. Now, moving on from lines, and we'll discuss lines more on the next assignment. Well, I mean, there's some reviews and quizzes and stuff. Eventually, it's going to get to a point where we might be ahead of, the class might be a little ahead of where you are, because they're going to have days for you're going to have reviews and so forth. But it'll all even out ultimately when, okay, we'll set aside some days to take quiz, for those of you that want to take your quiz in the, or test in the classroom, rather than doing it at home with the monitor system. So if you have a Chromebook, for instance, if that's what you're using, then you'll bring it to class and take the test sort of the old-fashioned way rather than with the monitor. So if there's no exponents, it's a line. If there's an exponent in the equation, it's not a line. Like number 3, is this going to be a line? No. It's a graphs of quadratics. We've used that word before. Quadratics means that there's an x squared. Oops. There. Quadratic means that there's an x squared in the equation. The graph of a quadratic is a U-shaped figure that we'll discuss probably after spring break in more detail. Maybe before spring break. Yeah, it'll be before spring break, which might seem like a long time away. This is the spring semester, isn't it? Okay, good. Quadratics are U-shaped figures that open either upward or downward. Okay?
They're both called parabolas?
And they're both called parabolas. Mm-hmm. You may have heard the phrase a parabolic dish or something, satellite. What do y'all think those things are they're shooting down? My nephew, he's always on, the more bizarre stuff, and he's convinced it's UFOs. Or do y'all think they're balloons? I'm sort of hoping they're balloons. He was like, oh, he hopes it's a UFO. And I was like, oh my gosh, I hope that doesn't happen till, well after I'm gone. But y'all know what I'm talking about? I'm reminded of something of February 2020 when I was talking to the class about this virus and maybe the school will have to close and absolutely no one out there knew what the heck I was talking about. I was watching the video on YouTube one day just because I was convinced that I had a memory of doing that. I thought, it's got to be there. Find it, and I found it. There it was in February, and the students, y'all know what, now you know what I'm talking about, right? The coronavirus and all of that was starting, the pandemic and stuff. So there I have that little video in February talking about it. My students thought I was insane or something. But anyway, I've talked long enough. We need to do number 3. It says, for the equation y equals x squared, create this table with at least 3 ordered pairs that are solutions. Well, we're going to get exactly 3 ordered pairs and then graph it. So the first thing we'll do is fill in this table, and then we'll see how to use the graphing tool. Okay, so let me write the table. I have to say, I really like this notebook. I think everything gets neater with these, all the little grid lines. Oh, -2, 0, 2. What are y'all thinking I'm going to be doing on this one? With those numbers under the X? Could y'all say in words what I'm going to be doing? For this first one, You take the -2 and plug it in for x. So is this something you can do without a lot of writing? -2 times -2 is 4. So we're going to get 3 ordered pairs. There's the first one. Now, plug in the 0 in. 0 squared is just 0. There's not a lot of writing here. If you're thinking, oh wow, it looks like he's just writing down the answer. Oh, it's not a lot of stuff for me to do other than you take the 0, plug it in for x. 0 times 0 is 0. What about this red 2? What are we going to get for the y value? A red 4? 2 squared, 4? And let me punch those numbers in. -2, 4. This is one where you have to punch in all the numbers and check it just once. 0, 0, and 2, 4. We'll say, check the answer. I'll click to enlarge, which doesn't really enlarge it, but it shows all of this area over here. And now we've got to choose the tool to use. We will not use the line tool. With lines, there should be no exponents. The tool right beside it, it looks like a V. If you hover the mouse there, it says absolute value tool. That's actually the trickiest tool on all of these, but this is not an absolute value. How do I know it's not an absolute value graph? There's no absolute values in the problem. Let's look down here. 3-point quadratic tool. I'm calling these a parabola, but we aren't actually going to define them as a parabola yet. What it's calling it is just 3 points. Do we have 3 points there? And quadratic means x squared. That's the tool you're going to use. Let me make a note of that. Use 3-point quadratic tool. Use the 3-point quadratic tool. Alright, so I'll click there. Now it says click the graph to plot the first point. What was that first point? -2, 4. There it is. Now click the second point. Is that second point 0, 0? And the third point, 2, 4. Notice how it's making a knot. Let's see, 2, 4. Did I do that? 2, 4. I'll say save it, and it'll move the graph over there. And then check my answer. Any questions there? That 3-point quadratic tool is actually a pretty easy tool to use, but as long as you have the table here. If you're thinking to yourself, wait a minute, what if they didn't have a table? What if they hadn't given you this table? What would you do? Well, you know what? If they don't give you the table, just use any negative number, 0, and any positive number. Sometimes students say, well, I'm always going to use -2, 0, 2 for 3-point quadratic. That's fine. If you want to use -1, 0, 2, or any negative number, 0, and a positive number, it'll work. In case you're wondering what the heck do I mean, number 7. It's a quadratic, and we have a 3-point quadratic tool. But what did they not do? They didn't give you the table. So if you want to just use the same table of values from problem 3, -2, 0, +2, that's fine. Don't get really large, by the way. Okay, so if you get to choose the numbers, theoretically, if you wanted to put 100 in, or excuse me, a 10 in for x, you could. That's theoretically. Looking at this graph here, it's only between -10 and 10, and the y values are only between -10 and 10. If I put a 10 in here for x, would it fit on this graph paper? No. So I would either use -2, 0, 2, just like number 3, or if you want to use -1, 0, +1. Okay? But let me write it down. Number 7. If you're wondering about number 4, I'm going to go back to it. But I wanted to do this one while you were thinking about the 3-point quadratic tool. In order to use the 3-point quadratic tool, you have to come up with 3 points. Theoretically, for the 3-point quadratic tool, fill in this table. It doesn't have to be -2, +2, and -2, 0, +2. It could theoretically be plug any negative number you want in for x, then plug in 0, and then plug in a positive number. Now that's theoretically, but again, you got to make sure your numbers aren't so big that they're off the screen. Like you couldn't plug 1,000,000 in for x. You couldn't plug 100 in for x, because that xy axis, it's only between -10 and +10. So I'm just going to plug in. Well, I'll let someone decide for me. Do y'all want me to use -1, 0, 1, or do you want to use -2, 0, 2? I don't think I could use -3, 0, 3. If I plug a 3 in here, and my y value is going to be too big. Oh, by the way, do y'all remember the "Please excuse my dear Aunt Sally"? If I plug a 3 in here for x, what am I going to do first? Multiply or square? Square. Okay, if you plug a 3 in, 3 squared is 9, times 2 is 18. Is that too big for my graph paper on the computer? Yeah. So I think I'm going to use, I'm just going to use what they used on number 3. -2, 0, +2. Okay. To use that 3-point quadratic tool, you've got to get 3 points. One of them has to be 0, and then a negative and a positive. Okay? So let's see. Be careful. Plugging in the -2 for x. You put the -2 in for x. What are we going to get for y? -2 times -2 is 4. +4, right? Times 2. Is that are we getting an 8 here as our first point? -2, 8. Now plugging in a 0, is that going to be pretty easy? How will I plug a 0 in? You're just not talking. Plug in a 0. 0 times 0, that's 0 squared. 0. Times 2 is 0. One more number. Plug in the 2 in for x. It'll be 8 again. Make sure you're getting 8 and not 16. If you're thinking, no, it should be 16, you're multiplying before you're squaring. In the order of operations, you do exponents before you multiply. So plug the 2 in, square it, and then multiply by 2. 2 squared is 4 times 2 is another 8. Now those ordered pairs, we're not gonna, you don't type them in or anything. You just skip down to the graphing part. You say 3-point quadratic, and it walks you through. Okay, the first point, -2 up 8. Am I -2, 8? Yeah, I am. I look in the right-hand corner of that yellow rectangle. I'll click there. Next is 0, 0. So it's basically just connecting the 3 points. At this point, when you put the second point in, it looks like a line, doesn't it? But it's not a line. You plot the last point, 2, 8. Right 2 up 8. I'll say save and check. Any questions on here? If it's the 3-point quadratic tool, on problem 3, it'll tell you the table to fill in. On problem 7, you've got to know, okay? But I would plug in either -101 or -202. Don't go any bigger because my numbers would get too big for the graph paper. Okay? And the next things. The next thing we're going to graph are called cubics. Oh, wait, that's hard to read. My pink writing, my pink ink. Oh. I don't want to go over this. It'll really be blurry. Can y'all read that? Cubics contain an x cubed. Okay? Cubics contain an x cubed. Okay? And the shape of a cubic equation, there's not a formal name for it. Generally, students will refer to it as a squiggly. Let's go back to number 6. Okay? When you see the shape, it's just going to look sort of like a squiggly line. There's no formal name. Like for quadratics, what is the formal name for a graph of a quadratic? A parabola. Okay? And for the cube, there is no formal name. You'll see it's just sort of a squiggly line. So let me write down number 6. It says for the equation y equals x cubed minus 5, create a table with ordered pairs. They give you the table. Let me write it down. Ooh. Okay. So first thing we're going to do is plug a -1 in for x. Then we're going to plug a 0 in for x. A +1 in for x. And a +2 in for x. Notice I can't have very large numbers. Back in the olden days when we just did everything with paper and pencil, you know, they could give you some big numbers to plug in. And you just have to have a really big sheet of graph paper. On this one, I suspect it's going to be between like -10 and 10. Okay. So, start off plugging the -1 in. I'll write it right here. -1 cubed. That's -1 times -1 times -1. Well, -1 times -1 is +1 times -1. Is this going to be a -1 minus 5? The -5 is just from right here. What are we getting for this first y value? -6. Are y'all following what I've done there? Any questions about my logic? Ooh, on the red one, I think plugging the 0 is going to be easier. Am I right? If I plug a 0 in for x. 0 times 0 times 0 is 0 minus 5. Is that just going to be a -5? Let's see. What about the next one? 1 cubed. 1 times 1 is 1 times another 1 is 1. Minus 5. 1 minus 5 is -4. Okay. Any questions how I'm getting these numbers? What about plugging a 2 in? But don't say 6 immediately. 2 cubed. It's not 6. 2 times 2 is 4. Times 2 is 8. Y'all agree with 8? Minus 5 is 3. So, I will now go punch these numbers in so it'll tell me I've done them right. And then we're going to use a cubic tool. Let's see, -6, -5, -4, +3. Oh, okay, well the graph paper here is -20 to +20. Now, on the y-axis, ooh, I don't like the looks of this. Look at how they have it set up. On the x-axis, you see it's really big marks. But the y-axis, in order to get it all the way up -20 to +20, it's pretty big. I mean, they're real small. But anyway, what tool are we going to use? Let's see. I'm going to choose my tool. It's not a line tool. Not an absolute value tool because there are no absolute value bars anywhere there. It's not a 3-point quadratic because we have 4 points, not 3. It's not quadratic because there's an x cube. Look at the name of this one right here. 4-point cubic. Do you think that's the one we're going to use? Yes. By the way, this circle tool, you'll know when we're going to use that. We'll have an assignment on nothing but circles. Okay? So I will click the 4-point 4-point cubic, and then follow the instructions. Click the graph to plot the first point. What was that first point? Left 1, down. See, especially like this, if you're like, oh wow, am I at -1, -6? Look in the yellow rectangle. There it is. So I'll click it. Now it says click the second point. Second point is over 0, down 5. Am I at over 0, down 5? Yep. Now click the third point. The third point is right 1, down 4. Oh wow. Right 1, down 4. Sort of, am I at right 1, down 4? Yes. At this point it's still looking like a line, isn't it? But once we plot the fourth point, right 2, up 3, it turns out it's more of a squiggly line than anything else. Right 2, up 3, yeah. I'll say save it. There it is. Oh, nothing I can do. Check. Okay. Any questions? Oh wow, you can impress people with terminology. What did you do today in class? We graphed a 4-point cubic equation. Okay? Is it hard? No, not really, right? I mean, you've done harder stuff, right, this semester? Well, we keep seeing that little tool that says absolute value tool. So let me absolute value graphs. If there's an x square, this x square, you have these U-shaped figures called parabolas. If you see absolute values in the equation, then the graphs, they don't have a fancy name, they're just V-shaped graphs. By V, I mean there's a sharp point. And that sharp point has a special name called the vertex. Theoretically, and you'll see this in once we get to our lesson over nothing but parabolas, this little point here is called a vertex also on a parabola, but for our purposes, we don't need that yet. I'm about to write a statement down, but before I do that, it might make more sense if you actually see what one of these graphs looks like, or one of these equations right here. This is can y'all see those absolute value bars? They're mighty dim, okay, but it's an absolute value of x minus 7. This is going to give us some numbers to plug in. Before we do that, I want to go ahead and finish my brief discussion of the vertex. The vertex occurs at the x value that gives a 0 in the absolute value bars. That's going to be significant in a moment. vertex occurs at the x value that gives a 0 in the absolute value bars. When we look at number 5, just looking at this equation, what x value would give us a 0 inside here? Y'all figure that out? I'll give you a hint. It's not 1, 2, 3, 4, 5, or 6. 7. Would y'all agree that if x were 7, we'd have a 0 in there? Yeah. That's where the vertex is. That's going to be significant in a moment. But right now, we'll just write down the equation and start plugging in the numbers. Y equals the absolute value of x minus 7. It looks like they made the absolute value bars real dim here. I'm going to try to make them brighter, or darker, I mean. Let's see. I'll make my XY table. And there's a -3 under the x column. So in words, what is that telling me to do there? Plug a -3 in for x. So here. Let's plug a -3 in for x. Now be careful. Plug in a -3 in for x. We have -3 minus 7, which is what? -10?
But it doesn't absolute bars, so without it, it'd be just +10.
Oh, did y'all hear that? Beautifully said. -3 minus 7 is -10, but that's in absolute value bars, so it should be +10. Remember, the absolute value of -10 is +10. There's 1 point there. +10. Check it. Now it says plug a 7 in for x. So we're plugging a 7 in for x now. So we'd have y equals, what number is going to be inside those absolute value bars? 7 minus 7 is 0.
So it'll still be 0.
Which will still be 0. Going back to something I said a few minutes ago, the vertex occurs at the x value that gives a 0 in the absolute value bars. This green point right here is the vertex. That's going to be significant. Oh, wait, I didn't put the 0 in. You want me to do that so that you know I didn't mess up? And now a 14. Let's plug a 14 in for x. If I plug a 14 in for x, what am I going to get?
7.
Yeah, I think you're right. 14 minus 7. 14 minus 7 is just 7. And the absolute value of 7 is just a 7. Of all the graphing tools, these absolute value tool is the most difficult to use. If not difficult, tricky. Okay? Because when you see these 3 points here, what do you think you're going to do? You're probably thinking, okay, we're going to plot the first point, plot the second point, plot the third point. Let's actually see what it says. When you click absolute value, so they're telling you it's going to be a B, okay? What does it say? Does it say plot the first point? No, it says plot the vertex. The vertex is the one that gives the 0. Here, you've got to plot that vertex first. If you plot negative 310, you're just going to get the wrong graph. It's not going to say, hey, that's not the vertex. I've got to plot the 7, 0 first. Oh, wow. A lot of little rectangles here. Let me see. Oh, am I at 7, 0? Yeah. Once you plot that vertex, you move your cursor around and it'll show you every little V shape that has 7, 0 as the vertex. What does it say to do now? Plot another point. It doesn't matter which of the other 2 points you plot, but you've got to plot the vertex first, then either plot negative 310 or 14, 7. Which one do y'all want to plot?
Negative 310.
Negative 310, okay, so negative 310, am I? No, I'm at negative 411. How about, now I'm at negative 310? See, with the absolute value graphs, all you're plotting are 2 points, the vertex and one other point. And you might say, well, wait, it gave us 3 points. Yeah, every day I go to work and there's all these streets I never drive down. I just got to know to ignore those, okay? Life is like that. You get more information than you need. So, wow, can you imagine if UFOs are up there listening to me? They come through space and time to hear me teach them some algebra.
So you only had to plot the 2, you didn't have to
Exactly.
do the
That's the thing different about the absolute value graphs. It's not, you don't plot all 3 of the graphs. You plot you don't plot all 3 of the points. You plot the vertex and then one other point. I know I'm sort of jumping around, and you'll probably do the problem just in chronological order, but, oh wait, that's not the same problem. I thought I looked to make sure we didn't wind up with the same problems. Oh, no, that was x minus 7. Okay. Number 8, what's different here? Does it give you the table? No. So how do you graph an absolute value if it doesn't give you the table? Well, this is problem number, you know what? I need to look back. I messed up. Oh gosh. This is not number 7 I just did. It was number 5. I'm sorry about that. Okay, it was number 5. Okay, the absolute value one. And the other absolute value one is problem 8. Y equals absolute value of x minus 4. Y equals the absolute value of x minus 4. Oops. I was about to say, they gave us the numbers. No, they didn't. If you remember how this tool works, the first thing it says is plot the vertex. Then after that, plot any other point. So, I'm going to make an XY table. first point I'm going to label on here is the vertex.
You can't see anything here.
Uh-huh. Thank you. Okay, I'll make an XY table. I'm going to find the vertex first because that's the first point I've got to plot. Instructions will say plot the vertex. I'm not going to write out three ordered pairs like right here. In order to use that tool, all you need is the vertex and any other number. Well, how do we find that vertex? Oh, it's 4. The vertex is at the x value that gives you a 0 inside the absolute value bars. Y'all agree that 4 is the number that would give you a 0. If you plug the 4 in for x, wouldn't that give us a 0 inside the absolute value bars? These are neat little graphing tools. I remember right when this sort of technology started coming into existence, teachers, they biased.
I'm a little lost how you found that.
Oh, okay. Just based on how I said to find the vertex. It's got to give you a 0 inside the absolute value bars. On problem 5, like, what number would have given you a 0? Well, 7 minus 7 would give you a 0. Here, what number minus 4 would give you a 0?
And then so y would just automatically be 0?
Uh-huh.
Okay.
4 minus 4 is 0. And as you said earlier, the absolute value of 0 is just 0. Okay? Now we need any other point. Plug anything you want in for x other than a 1. Don't use 100. That won't be on the graph. Okay? So plug a 1, 2, 3, 4. Heck, what about a 5? Would 5 be pretty easy to plug in for x? Why am I choosing 5? That just seems like an easy number. If you look at doing the math, 5 minus 4. If I plug a 5 in for x, five minus 4 is 1. Okay, and the absolute value of 1 is 1. Now, this point was completely up to me. The vertex, no. I've got to plot that one. So, click to enlarge. And absolute value. Notice it says plot that vertex. Right 4, up 0. And now plot another point. Well, I found that point 5, 1. See, am I at 5, 1 now? Yeah. And I will save it.
I hate to ask another question, but I was writing a little note about how you got the vertex, but then you were working on the other part.
Oh.
I don't know how you got the same one.
Oh, choose any number you want, plug it in for x. Okay? Like you could plug a 1 in, 1 minus 4 would give you a negative 3. The absolute value of negative 3 is 3. It doesn't matter. But don't use 100, because then 100, it wouldn't be on the graph.
Okay.
Okay? Why did I choose, why did I decide to use 5? Well, I looked at it and thought 5 minus 4. I can do that real easily in my head. Okay? So this is just choose it. Choose any number you want. Other than the vertex. Don't use a 4. And plug in for x. I would always use the number real close to whatever you have for the vertex. If that x coordinate of the vertex is 4, I'd use 3 or 5. Okay?
Okay.
Now, did I check that? No, I didn't. Check it. Okay. Now, why have I not done number 4? Well, number 4 has a square root in it, and there is no square root tool. So this is back to the way it used to be 15 years ago when all of this was brand new technology. 15 years ago? No, it wasn't all multiple choice. 20 years ago, everything was just multiple choice.
It wasn't that long.
Oh.
It was like 14, 15 years.
Oh,
But,
okay.
I mean, when I was in college last time, we did it all on paper. We didn't have online, so.
Well, let me see. When did I
That
start?
was like 2013, 2012.
2013, I think, was when I started. No, maybe it was 2012 when I started this. But it had been around, just very few people were using it. Now, here's the shocking thing. There are more schools using this stuff here than anything else. The majority of students, math students in the nation, are using Pearson MyLab for their algebra class. Okay, well, on this one, we're just going to plot some points, and then I'll blow up each graph here. Okay? But if you look at the graphs, it's hard to see them, but can y'all see they're all between negative 10 and 10? Is that what it looks like? Between negative 10 and 10? So let's just choose some numbers and plug in, but don't decide to plug in 1,000,000. It's not on the graph, okay? So, also there's something you got to be careful about. Can you just plug any number in here? When you're looking at graphs, there are no imaginary numbers. For instance, could I plug a 0 in for x? Because if I plug a 0 in for x, that gives me a negative 3 under the square root. And that's an imaginary number. No, there are no imaginary numbers on the x-axis and y-axis. Okay? You don't want a negative 1 under the square root symbol because that would be an I. There's no I's on the x-axis and y-axis.
4 minus 3.
Okay, 4 minus 4. So you're saying plug a 4 in for x. 4 minus 3. What would that give me for the y value?
1.
A 1. Okay. Is there a number smaller than 4? I could have put a 2 in. But is there a number smaller than 4, but not 2? 3? What's 3 minus 3? 0. So 3 is the smallest number you can use. Okay. Then you could plug in 4. Oh gosh, if I put in a 5, that would give me a decimal number. That 5 minus 3, the square root of 2, that's 1.4 something. Let's try to avoid decimal numbers. What's the next number that would give me, I have an idea. Let's work backwards. What x value would give me a 2?
5.
2, it'd be a 2 under there, but I don't want the square root. 7? Did I hear 7? If we plugged a 7 in here, 7 minus 3 would give me a 4. And the square root of 4 is 2. Do y'all see why I'm saying 7? If x were 7, if you want to get out your calculator and get some decimal numbers, that's fine. If I just started, now I'm doing this the old-fashioned way. I draw out my rectangular coordinate system. And just start plotting. Right 3 up 0. 1, 2, 3. Right 4 up 1. Let's see, what's that next one? Right 7 up 2. 1, 2, 3, 4, 5, 6, 7. Up 2. And I can keep putting bigger and bigger numbers in there. If I just started connecting the dots, it just sort of does like that. Okay? But what you would do probably is once you have a few points, just start looking at each answer choice. Oh wow, this is -10 to +10. Each one of these marks is what? 2, 4, 6, 8. Each mark is 2. Is the point right 3 up 0 on the blue line? I mean on the blue curve. So right up here would be right 3 up 0. Oh wait, no. Oh gosh, can I do this? We were going to plot right 3 up 0. Oh, that would be right out there. Let's see that. So I'm thinking the answer is not part A. Okay. Oops, let me close that. Oh, let me stop this. Oh, back to you. So I'll close that. Is it, oh, see? Yeah, a square root graph has this same shape. It doesn't matter if it's x minus 3, x minus 7, x plus 5. It's going to have just this little smooth, slowly going up curve shape. And it has a definite starting point. Okay? But there's nothing real sophisticated here. Just looking at your points that you have and looking at the graph. Okay, it's definitely not D. But again, if you go back to that first point we found, right 3 up 0. Or heck, the second one, right 4 up 1. You see, that's not on the graph. Any questions there? So which one did y'all say it is? C? Okay. And it's been a while since we've had some formulas. So we end this assignment with some formulas. Okay, so I'm going to state a couple of formulas. We're going to look at something called the distance formula. What that does is calculate the distance between 2 points. And we're going to have something called the midpoint formula. That'll calculate the point right in the middle. Distance formula and midpoint formula. In order to state this formula, I need to refer to 2 ordered pairs. Okay? To find the distance between 2 ordered pairs. So given I'm going to put some subscripts on here. These are not exponents. I'm going to put a subscript of 1 here and a subscript of 1 right there. What that means is this is the first ordered pair. Ordered pairs are always x, y. So first x, first y. And what do y'all think I'll use to denote the second ordered pair? X, what do you think the subscript will be? 2, y, 2. Those subscripts are just numbering. First x, first y, second x, second y. What I've written here, there's no exponents. Okay? What I'm about to write will have some exponents. It's the formula. D for distance equals. It's going to look terrible. See, that's a square. Oh, wait, that's a square here? Oh, wow, trying to correct my smudged square just made it worse. Both of these things here are squares. It's second x minus first x squared plus second y minus first y squared. I think I'm going to go ahead and state both of the formulas right now, then we'll do an example illustrating them. But the problem that says find the distance formula also says find the midpoint formula. So I'm going to have both of the formulas at the same spot in the notes. The midpoint formula is an easier one, provided you know how to average. If you have two numbers and someone said average them, how would you average those two numbers? How do you average two numbers? It's not a tricky question. You add them together and then divide by the number of numbers 2. All you're going to do to find the midpoint, you're going to average the x's. There's 2 of them, x1 and x2. So add them up, divide by 2. And then you're going to average the y's. There's 2 of them. Add them up, divide by 2. So here's the midpoint formula. Written out as a formula. To average the 2 x's, you would add them up. x1 plus x2. And then divide by 2. y1 plus y2, divide by 2, that's how you would average the y's. So to find the midpoint, you just average the x's, average the y's. Let's do this with some numbers to see if it makes any more sense. Let's see, number 9. Oh, wow, okay. 9. We're given 2 ordered pairs. The first ordered, for the point P, -9, 25. And the point Q, -4, 28. We're going to find the distance, which they're denoting D for distance from P to Q. Okay? I just would say just D. And then find the coordinates of the midpoint. They're calling the midpoint a capital N. So we're doing 2 things. What's the distance between the 2 points? Which ordered pair or which point is right in between those? I wrote it without bothering with any of that P and Q. Start off. I like to label each ordered pair. X1, Y1, X2, Y2. Make sure you're labeling them correctly. First X, first Y, second X, second Y. A common mistake that students will make, they'll go X1, X2. No. Ordered pairs are XY, XY. Now to find the distance, You know what, I think I'm just going to recopy the distance formula. And you might say, well, wait, why are you restating it when it's right there so I can push my paper up a little? Okay. And it doesn't have that smudge mess right here. There. Now just plug in, right? In place of the x2, put a -4. In place of the x1, what am I going to put? -9. Be very careful. Why am I saying that? Well, oh, my lines are starting to get wobbly. I guess I'm writing too long. Okay, so x2 is -4. x1 is -9. When I plug a -9 in here, watch out. We have the black minus is from the formula. And I don't know if you can tell the colors, but this is a purple -9. What's happening right here? It's going to turn into a positive. Minus and negative is a plus. I'm glad that this first example worked out or regenerated with some negative numbers in it. I remember one semester I kept wanting to do these problems and there were no negatives. It wouldn't regenerate with negative numbers there. That's those negative numbers where it can be tricky. Like for the y's, y2 is 28, y1 is 25. See, that's not tricky, 28 minus 25. But it's here where we have these minus and negative. Watch out. The minus and negative, we can think of it as a plus. So what number are we getting inside this first set of parentheses? -4 plus 9. I'm thinking it's 5.
Okay.
Just a 5. See that? -4 plus 5, plus 9 is 5. Now the other one's easier. The 28 minus 25 is just a 3. Now, let's see, simplifying this, the 5 squared is 25, 3 squared is 9, so we have under the square root of 25 plus 9, which is 34. Now, going back to what we did the very first day of the semester, can we simplify square root of 34? Now, 4, 9, 16, 25, there's no perfect square that divides evenly into 34. So, the distance, we just leave it as square root of 34. Any questions there? Square root 34. Okay. Now the midpoint. Find the midpoint. You're just going to average the x's and average the y's. Add up the 2 x's, divide by 2, add up the 2 y's. So they're calling the midpoint M. Add the 2 x's. So x1 is -9, x2 is -4, y1 plus y2, I'm adding the y's, 25 plus 28 let's see, what's that top number there? Negative 9 plus a negative 4, is that going to be negative 13? So what is that, about negative 6.5? Not about, it is negative 6.5, but we're going to leave it as 13 over 2. My math lab doesn't like mixed numbers. 28 plus 25, 53. Neither of those can be reduced. I guess you could reduce them as mixed numbers or decimals. There's a general rule of thumb. You don't use a decimal in this class unless it's talking about money. And there'll eventually be some word problems where maybe we're dealing with profit or revenue. So we type in the ordered pair. What is it? Negative 13 over 2. Don't put the comma down there in the bottom. Right arrow, comma, 53 over 2. What's going to happen if I say check my answer? Yes, say it.
Put the parentheses.
Yes, your answer must be in the form of an ordered pair. Make sure you've enclosed your answer in parentheses. Okay. Very observant of you. Parentheses and parentheses. Okay. What time is it? Let's do one more. If I'm correct, starting with number 11, it's just a review from other stuff. Yeah, so let's do number 10, just so you see two of these distance midpoint problems. So, oh, okay, this one has negative numbers in it too. Good. So we have the ordered pair. Ooh, is that a negative 18, comma 19, and a negative 2, no, negative 6, and 24. Same instructions, find the distance, find the midpoint. So, I will call the... It is 13. Oh, okay, I'm sorry about that. Oh, good, I'm glad you pointed that out. It is a negative 13. Oh gosh. Negative 13. So I wanted to ended up with a nice, neatly worked problem, and right off I've messed it up. Okay, first X, first Y, second X, second Y. I always like to label X1, Y1, X2, Y2. Now let me write down that formula. Second X minus first X squared plus second Y minus first Y. Now we just start plugging in. Watch out for the negatives. Okay? negative
Faster than the
6
paper ones, hey.
minus a negative 13. I'm going to go ahead, since I have the black minus from the formula, I'm about to write a purple minus. Look how I'm going to write the purple minus. Okay? So that minus and negative becomes a positive. Keep going.
Minus 19.
Now that's the easier one. 24 minus 19. Wonder if we're going to get something we can simplify under here. Okay, so negative 6 plus 13, is that 7? What about this one? The 24 minus 19 is 5?
Yeah.
So 49 plus 25. Are we going to get a 6? Oh, no. No, I was about to, I thought for a second we were going to get a 64 under there. It's going to be a 74. So does it simplify? No. 2 times 37, aren't those the only numbers that will give you 74? Both of those are prime, so. Any questions on that square root of 74? We're still not finished. Square root of 4. We have to do that midpoint stuff. Okay? What color was I using? Midpoint. To find the midpoint, you add up the x's and divide by 2.
Negative 13 plus negative 6.
Yeah. Okay, so
Negative 6 and 24.
okay, I'm rushing. I'm going to catch up with you in just a moment. Okay, so negative 13 plus a negative 6, that'll be a negative 19 over 2. And what about the y's? 19 plus 24 all over 2. This is pretty much working out just like the other one did. By that I mean it's going to have a fraction in our answer, isn't it? Negative 13 plus negative 6. Are y'all getting a negative 19 over 2? And what else? 43 over 2? Is it 43? And can't reduce it any other than writing a mixed number or a decimal, so we'll just type it in like that. Don't make the mistake I did on the first one. Be sure to put your parentheses. Parentheses. Negative 19 over 2. Don't put the parentheses down there with, the comma down there with the 2. Go right arrow, then comma. 43 over 2. Don't do this. It'll count it wrong. That parenthesis shouldn't be down there with the 2. Right arrow, parentheses. Starting with 11, it's just reviewing old stuff we've already done. So, are there any questions? A nice little assignment. Well, if I may say so myself, since I'm making them know. I mean, just a lot of nice little graphing stuff. Okay, I'm really pleased with it. Any questions? Remember, for the absolute value, plot the vertex first. Okay? Remember, one semester I had 3 classes back to back, and the next morning I had 35 students emailing me about the absolute value, because they were trying to plot the points in order rather than getting the vertex. So I'm going to go ahead and call it quits.